Hello and welcome back, fellow path integrators. Today we're taking a little detour into the world of complex numbers, and we will find a very peculiar answer to the question, what is the fourth root of minus 16? Well, to answer that question, we will have to look at the complex plane. Each complex number, real numbers included, corresponds to a point in this complex plane. Apart from expressing the complex number z through the coordinates x and y, we can also express it through the distance from the center r, which, according to Pythagoras, is the square root of x squared plus y squared. And to express the complex number z, we not only need the distance from the center r, but we also need the angle phi. And according to Euler, we then can express the complex number z as r times e to the power of I times phi. And this formula can be rewritten to r times, and then in brackets, cosine of phi plus I times sine of phi. So now let's take an exponent of z, and what we will get is r to the power of n times e to the power of phi times n. Well, when we plug that into our formula that we have above, then we will get r to the power of n times, in brackets, cosine of n phi plus I times sine of n phi. And this makes us conclude a formula for the nth root of z, which is zk, so the kth root of our complex number z, is the nth root of r times the cosine of phi plus 2 pi k divided by n plus I times sine of phi plus 2 pi k divided by n. And k starts at 0 and ends at n, so we will have n roots of the nth root of z. So let's go back to our original problem, the fourth root of minus 16. We will have to use the formula r times cosine of phi plus I times sine phi to express minus 16 with this formula. And we can do this by plugging in pi for phi. So minus 16 will be 16 times cosine of pi plus I sine of pi, because the cosine of pi is minus 1 and the sine of pi is 0. And r in our case would be 16. So now we can use the formula for the kth root of minus 16, and we just have to plug in for z0, we plug in for k0, so we get pi quarter as the argument of cosine and sine, and this will be the square root of 2 divided by 2, and in the end our first root will be the square root of 2 plus I times the square root of 2. Then the second root, z1, will be as an argument 3/4 times pi, both for cosine and sine, and we will get minus the square root of 2 plus I times square root of 2. And in the same manner we will continue with z2, and we will get minus square root of 2 minus I times square root of 2, and the last root will be the square root of 2 minus I times the square root of 2. So what does that mean? How can we imagine that now? So let's take a look at the roots in the complex plane. Our first root will be here in the right corner, the square root of 2 plus I times the square root of 2. The second root will be in the left corner, in the left upper corner, minus the square root of 2 plus I times the square root of 2. The third root will be in the down left corner, and in the last corner we have the square root of 2 minus I times the square root of 2. So I hope you liked the way we found out about the real values for the fourth root of minus 16. If you liked that video and if you would like to see more of that content, leave a like, it would be really nice. Subscribe to my channel, that helps a lot, and leave me a comment. I like chatting with you guys. Okay, see you in the next video. Bye.